Hello, algebra students. So hopefully you've already taken a look at your enrichment for the day. You've checked your answers and you're just looking for some help on maybe a couple questions that you didn't quite know how to do. So I'm going to walk you through the problems. I'm going to go a little quick, but hopefully you've already thought about them and kind of just looking for that one thing to help you fix your mistakes. So at the top here we're dealing with exponent rules. And I'm hoping you've already thought about your exponent rules. What do you do with negative exponents? What do you do with zero exponents? What do you do when you raise a power to a power? Those kind of things I'm going to assume you've looked at, kind of jump into how you do the problems. So for this first one, it's about negative exponents. I see negative exponents on the y and the z. And in a fraction, I'm going to think about changing from numerator to denominator or denominator to numerator. Since the x has a positive exponent, that's staying put. Is z to the negative fourth in the denominator? I'm just going to move z to the positive fourth up to the top. And y to the negative third in the numerator is going to move it down to the bottom. So x to the fourth, z to the fourth over y to the third. For number 2, we're raising this quantity 2, a to the fourth, b to the 0, all to the third power. Since there are no addition signs, we can give every single one of the bases in there that exponent of 3. So what does that look like? It looks like 2 to the third times a to the fourth to the third times b to the 0 to the third. 2 to the third is 8. A to the fourth to the third, when we raise an exponent to an exponent, we're going to multiply. So that is a to the 12th. B to the 0 power, hopefully you remember, is equal to 1. And 1 to the third is equal to 1, so we would do 8 times a to the 12th times 1, which just keeps it 8 times a to the 12th. Number 3, this negative out front here, that's not going to do anything to the problem. We're just going to see it at the end. We are raising g to the negative second to the negative third power. When we raise a power to a power, we're going to multiply. So that's g to the negative second times g to the negative third, which is g to the sixth. And then again, do not forget your negative out front, which is unchanged by those exponents. Number 4, to me, the easiest way to think about doing this one is to kind of separate our bases. So I'll do 12 over 28. We'll do w to the 6th over w to the negative 5th. We'll do x to the negative 4th over x to the negative 3rd. And finally y to the 7th over y to the 2nd. 12 over 28, that simplifies, or I guess I should say they're both divisible by 4. So when you divide 12 by 4 and 28 by 4, that leaves us with 3 over 7. For the w's, how I like to think about this, I see that negative 5th power in the denominator, which is going to move 5 w's to multiply up top. And when you do w to the 6th times w to the 5th, we add those exponents, giving us w to the 11th. For the x's, they both have negative exponents, so they're both going to flip-flop spots. And do some work on the side over here. That's going to give us x to the 3rd over x to the 4th. How I like to do these ones, I like to think there are 4 x's being multiplied in the denominator, only 3 in the numerator. We're going to cancel those 3 on top with 3 on the bottom. And if we cancel 3 out of those 4, how many are left? Just 1. So we're going to have an x to the first power, or x, in the denominator. Finally, with the y's, you can think about our subtraction rule. I like to think about canceling 2 from the bottom, canceling 2 from the top, leaving us with y to the 5th in the numerator. Now we move on to 5. This one, definitely a little tricky. The difference is that plus sign. I still like to think about raising stuff to the second power as multiplying it by itself. So 4 plus x times 4 plus x. And you gotta distribute, foiling. Whereas b, since there's no plus sign, we can just go to exponent rules. 4 squared times x squared, which would be 16x squared. So the difference between these, I'll do some work really quick over here. Hopefully this makes sense. Combining our like terms, a actually simplifies to x squared 8x plus 16 because we distributed, we FOILed. Whereas b, we just got to use exponent rules because there's no plus or minus signs. Number 6, I'm going to run through really quick for Chapter 8, Polynomials. It's raised to the second power, so we're going to call it quadratic. There are 1, 2, 3 terms, so it is a trinomial. Second one over here on the right, third power, so we call that cubic. There are 2 terms. Binomial. The third one, you got to distribute first. So that's 2x squared plus 2x, which we would name a quadratic binomial. Second power, 2 terms. For this one over here to the right of that, we got to combine some like terms. X squared and 6x squared is 7x squared when we add them. 3x doesn't have a like term. Negative 1 plus 8, negative 1 plus 8 is positive 7. So just like the first one, we're going to name this one quadratic trinomial. Fifth one over here, there's no variables, there's one term, no variables, we call that a constant. One term, monomial. Constant monomial. For the last one, we're going to distribute that 5 over 10x minus 15. If you would like to simplify, that is 1/2 x minus 15, but that doesn't change the name. X to the first power, we call that linear. There are 2 terms. 2 terms means we're going to name it binomial. So that one is a linear binomial. Add or subtract the following polynomials. Make sure to write in standard form. So I'm going to go through and find some like terms. X to the 4th. I don't see any other x to the 4th, so that's just going to be part of our answer for x to the 4th. The next highest power I see is x to the 3rd. No like terms for that one either, and since we're adding, plus x to the 3rd. Finally get some like terms for our next degree. We got a negative 2x squared plus a negative 5x squared, and if you're careful with your numbers, it's going to be minus 7x squared. Please note the exponent doesn't change. The next one is 2x, which doesn't have a like term, so it's a positive, a plus 2x, and then finally 2 plus 1 for our constants gives us 3, so there it is in standard form. For the subtraction problem, it would actually be great if you rewrote the second quantity passing the minus sign. So I'm going to write that plus in the middle. I'm going to pass that minus sign to everybody. So we get negative 2x to the 3rd, positive 2x squared, and minus 5. That's how I would like for you to do these. It's going to generally lead to less sign errors. 6x to the 3rd plus negative 2x to the 3rd is 4x to the 3rd. 7x squared plus 2x squared is plus 9x squared. Minus 2x doesn't have a like term, and where commonly mistakes will be made, you pass that negative sign, we're adding a negative 5, so it is minus 5 at the end. Common error right there with that minus 5. Multiplying polynomials, you might not have to do it this way, but I'm going to use some boxes to help me organize. Again, you might not need it, but sometimes it is quite helpful. So we're going to multiply row and column. 2x times 3x is 6x squared. 2x times 1 is 2x. 3x times negative 5 is negative 15x. Negative 5 times 1 is negative 5. Now we're adding all these things together, so combine your like terms to get 6x squared minus 13x. That's where we combined our like terms. Minus 5. I'm going to do the next one a little bit quicker here. Same idea. So check out those, and when I combine the like terms, which actually cancel, we get x squared minus 9. I'm going to fill in the boxes for the rest, so give me 1 sec, I'll be right back. Alright, computer magic, boxes are filled in, combining like terms, x cubed plus 12x squared plus 34x, so minus x right there, minus 5. For that third one. The last one I'm not going to use boxes, because this one is distribution. 1/2 times 6 is 3, x times x to the third is x to the fourth, 1/2 times minus 10 is minus 5, x times x is x squared, 1/2 x squared, 1/2 x times 3 is plus 3/2 x, maybe wrote 1.5x, that is okay too. Our next problem, our last problem for this one, perimeter and area. So I'm going to draw a rectangle. Perimeter is adding all 4 sides of a rectangle, just adding up around. If we were going to label all the way around, we'd have an x plus 4, an x plus 3, an x plus 4, and an x plus 3. So for perimeter, we're going to add all those things. Common mistake, adding only 2 of the sides. Just make sure to add them all. Looking for our like terms, it's going to be 4x's, 4 plus 3 plus 4 plus 3 is 14. Now for the area, find the area of a rectangle, we do base times height. Base, let's call x plus 4, our height, let's call x plus 3, and we're going to multiply x plus 4 times x plus 3. I'm going to draw the distribution lines this time. X times x is x squared, x times 3 is 6x, 4 times x is 4x, 4 times 3 is 12. Combining our like terms, the area is represented by x squared plus 7x plus 12. Hopefully this helped you figure out anything that you got wrong on your way through. See you tomorrow.